Hi guys, welcome back to my channel. My name is Ramsey and today we're going to continue on our series, Building Effective Agents. So, we've come on a bit of a journey. Before we went through prompt chaining, which was about having LLMs handling tasks sequentially. And then we went to routing, where you had an LLM intelligently determine where to route a task depending on the type of task. And then we had parallelization, where an LLM could send a task to multiple different LLMs at the same time. Now, we're going to go into the orchestration the orchestration pattern for AI agents. It's called the Orchestrator-Worker in the Building Effective Agents article, but let's just call it orchestration because it's simpler that way. So with orchestration, you have a central LLM dynamically breaking down tasks, delegating them to worker LLMs, and then synthesizing their result. And you can see here they tell you when to use the workflow and so on. I'm just going to try and go into a little bit more detail here. So we have the topic parallelization. I did this nice little illustration with ChatGPT where you have like an orchestrator agent that takes the input and then breaks it into tasks and then gives each of these tasks to different worker agents. Now, in this, you have a central LLM, takes a task, dynamically breaks it down, delegates each subtask to worker LLMs, and then it synthesizes their outputs into a final answer. That's the core of orchestration. The difference between orchestration and parallelization, because you may have asked, isn't this the same as parallelization? It's very simple. With parallelization, you sort of know how many tasks you have in advance, right? So the subtasks are predefined. With orchestration, the subtasks are not predefined. You just tell it something, and then it sort of knows that there are like these single purpose agents that handle particular tasks. And it's the task of the LLM, the responsibility of the LLM to then take your instruction, break it down into granular tasks that match what these single purpose LLMs do that it has access to, and then pass those little subtasks on. And then when it gets outputs, it synthesizes them into one great output, right? Now, there are some key points. So, like I already mentioned, you can't know the scope of the tasks in advance, and that's the key difference between orchestration and parallelization. So, for example, let's say you have a code base and you're like, hey, I have a bug. Could you just like rewrite whatever modules that this bug touches? Well, you need the orchestrator to determine on the fly how many workers or how many files are going to be needed for the task you're giving it. Then there's tool calls. So like if you want to search and then scrape and then summarize, so you have the same thing, like maybe a URL or an article. And the idea behind it is that the orchestrator will choose the right tool chain for a subtask. So it has these tools, it comes up with a task like, for this particular thing you're saying, I know I have a searcher, I know I have a scraper, and I know I have a summarizer. Maybe I need to search first and then scrape and then summarize. So it's going to come up with this list of dynamic tasks, and these are going to be executed in order. And that's another huge advantage of the orchestrator, is that you can actually have the tasks ordered. So you can let the LLM decide what the order of the tasks is going to be, and then pass them on to some other kind of execution workflow. Now, that's actually an interesting kind of application of this. And for this video, I didn't make a workflow for that, but we can discuss it because there's actually a lot of use cases for that. It helps to be more dynamic. But for the purposes of this video, let's continue and see how we can sort of implement this with the tools that we have, like n8n. Right, so another reason that you might want to use an orchestrator is when you have the need to fuse many granular results, right? So again, granular results come from granular tasks. So if you have sub-agents that handle single tasks and you know all of these single tasks, and then you get an instruction, I'm talking to you LLM, I'm talking to you AI, you get an instruction from the prompter, you're going to decide how to break this general instruction into granular tasks that you can then delegate to the little army of LLMs that you have or agents that you have to carry out different kinds of tasks, right? So, again, they say here you have a central model and then it performs global reasoning after work is finished. Let's look at how you would implement this. So there's two versions. One would be that you would have like a node for an orchestrator, and then you would create the tasks, and then these tasks will be dynamically passed on to workers. And then finally, you'd have a node for synthesis. So you'd have like another LLM call here, which would have instructions on how to synthesize these results. So the orchestration and the synthesis. So not delegation. I wrote delegation here. I don't know why I wrote delegation. Technically, it's delegation and synthesis that are done separately. So this one delegates the tasks, and then this one synthesizes the results from those task runs. Another version of this is to have like one orchestrator that calls in workers as tools. Now, about agents, they have this ability to call tools, and you can sort of leverage this where an agent calls other agents as if those other agents were tools. I don't know what this says about a lot of things, ethically speaking, but so you have an orchestrator that creates these tasks and then calls the tools that say executes. So it handles the execution of the task as well by calling the individual tools to handle this, right? So here you have both delegation and synthesis happening in the same node, right? So the orchestrator does both the delegation and then synthesizes the results. Now, this can be as dynamic as you want. So, for example, you could have, and this is just like speaking from the perspective of n8n, you could have the orchestrator maybe even define new workflows on the fly. You could have it decide how many of each worker's call, the order of calling, and so on. It can be as dynamic as you want. For this particular demo, I'll show you a very simple use case. And then from that, you can sort of like, just to unblock, you can sort of like explore other ways you can use that. I have, because I'm going to jump right into the n8n demo. I have an orchestrator here, and it gets a chat message where you give it like a piece of text, right? And then basically it's supposed to summarize that text, get the sentiment of that text, and then get the associated keywords of that text. And it's supposed to output them in a particular way. So that's what the output parser is for, right? And then this AI agent is keyed into like different sub agents, like the summarization agent, the sentiment agent right here, and the keywords agent. It's a very simple demo. I'll show you guys right here. So you have an AI agent, right? And this agent's task is just orchestrator, right? So it's an orchestrator, right? And then the orchestrator gets input from somewhere. Maybe I can have like the input right here, and I can just write in there input. And then this input goes sort of into the orchestrator, right? And then the orchestrator has a bunch of tools. So it can call a summarizer, it can call a sentiment analysis agent, it can call a keywords agent. So you have, that's the summarizer, that's the sentiment analysis, and then that's the keywords agent. And then, you have each of these right here, right? So that, and then that, right? And then this is the summarizer, and then this is the sentiment analysis agent. So let's see, sentiment analyzer. And then this right here would be the keywords generator. So you'd give it a topic, like you remember last time we did Hacker News, right, in the last episode. So you'd give it a topic or like a post from Hacker News. It would summarize that topic. It would get the sentiment, so if it's positive or negative and neutral, and then it would generate the keywords associated with that. And then of course after that, it's just going to give you an output, right? So you have output right there, right? Okay, so let's build this, right? So first we want to build the subnodes. And this is just like generally speaking, if you're building a workflow in n8n, maybe even anywhere, and like you have like this kind of like general node or module or that kind of thing, and it's calling like subnodes, submodules, you want to build those first because they're very, very compartmentalized tasks. So the first one we're going to build is a summarization agent. As you can see, I already did a demo of this, but for the purposes of this, I'm just going to create a new one, and we are going to call it the summarization agent. It's very simple. Summarization agent. Since this is going to be called by another workflow, you want to have the trigger as being when executed by another workflow. So right here. And with this, you can sort of define the fields. Now, if you look at like sort of this workflow here, they're all getting the same input. They're all getting the text that you gave it. So it's going to be text input here, text input here, text input here, and then they give whatever output. I did this to make it as simple as possible to kind of like show this in action, right? So you have this, and you're going to, when you have the executed by another workflow node, you can sort of define the input. You can define using fields, you can define using a JSON example, and you can also make it like a wildcard, like accept all data that just comes to you. I would not advise that, but you can do it. So I like fields because then you can add them and then define their types and stuff. It's just like better for me UI wise. So I'm going to say that you're getting text, and the text is going to be a string, right? You can choose a type of the input, so Boolean, number, array, etc. Now note that depending on the type of input you choose, you might get some problems upstream, especially if like an LLM has to do a tool call and it has to output like JSON or an array or some other kind of structured data. You might have to really wrangle the prompts to get it to talk to specific tools. So you want to keep your input output contracts, which is what I would call them, like the kind of input a sub workflow or a tool expects and the kind of output it gives. You want to keep them very simple. This makes things so much easier. So if you have a string, you have a number, you have an array, try to keep it that simple. Things get more complicated actually when you work with arrays as compared to objects, but as long as you've got the input output contracts as simple and clearly defined as possible, then you can have all of these workflows working together. That's the point. So all of these are getting text. So this gets text. And then from there, we're going to call the AI agent node, which can be found here. And for this, we're going to, so it gets the input from the chat, and then we're going to give it a system prompt. So we know we want to return a specific output format, and we'll get into that later. But we're also going to give it a system message, just so we give it instructions. And we need to connect it to a chat model. So we're going to press this first plus on the far left and go for OpenAI. Again, I like OpenAI. And since it's just a simple summarization agent, you can just give it GPT-4o. That's okay. I'll go for the latest GPT-4o right there. Let's see. So we have a chat model in there, and then we may need to add an output parser. Why are we adding an output parser? Because I said requires specific output. So we wanted to output something like a JSON object saying summary and then giving the text of the summary, right? So this is why we would need to add an output parser here. And we can give it like the kind of thing. So I did a demo, and I always do these things so they help me like figure out some of these things like prompts and summaries. But you can define in the output parser how you want the output to look. You can either generate from an example again or define below. I like generate from an example because you can give it a generic example. It's always going to be an object. This is JSON speak. In JSON speaks, objects are like items, and an object has keys and values. So you can think of them as properties or attributes. I am an object. I have a property hands with a value 2 because I have 2 hands. I have a property head with a value 1 because I have 1 head. These property value pairs are what really constitute an object. So in this case, we have an object signified by this opening and closing parentheses, and it has a key summary with a string. Now, this is just an example because really, instead of string, I could just write, whatever I want. But the point is, you're kind of giving it like insight into how to expect the structure of this data. Now we need to give a system prompt in here. We already know the user prompt is going to come from the chat input. Why did I choose a chat input? Oh yeah, so it's not going to come from a chat input. It's going to come from this executed by another workflow node. This is actually interesting because when you have an agent, you can either choose for the input to come from the chat trigger node, or you can define below. And when you do that, so for example, I want the output from that, you can then have the output as a variable in here. But first, let's write the system prompt. So I have an example here, and the system prompt would be something like, you are a summarization agent. Produce a concise, information-dense summary of the input text in less than 3 sentences. Do not add commentary or quote the original text. Return only valid JSON matching the schema, and then you give it schema. So it's always important that when you're talking to an agent, you're giving it like tools. You give it the example of the inputs and outputs it should expect. And then, of course, these other stuff is just, like I did a bit of prompt wrangling, got help from ChatGPT, how to give it like negative prompts and stuff, tell you what to do, what not to do, etc. You get the vibe. So I'm just going to copy this, and then I'm going to paste it in here. And we have that. Now, the prompt message is going to come from the executed by a workflow. The beautiful thing about trigger workflows is, for example, if I click in test step, you can see it says text null, but you can always pin data and you can also edit data. So you can see this pencil icon tells you can edit. So I'm just going to say something here along the lines of, I definitely do not understand people who put pineapple on pizza. So whether or not you agree with that, it's a sentence. We can agree on that. And I'm going to save that. And now we have this pin text. So we can sort of feed this AI agent with some basic text in here. Now, what you'll notice is that after I have that pin text, when I come to the AI agent, I can actually access it from my input bar. So if I come to the prompt user message, which is where the text will come in, I'd have an expression mode. And then I drag that text in, and now it says that. So the user message always comes after the system message. So the way the AI will be called is it'll be given a system message first and then the user message. And the system message is where you enter the general instructions. If I test this step, you'll see that now it gives me output on a summary. So the user expresses confusion about people who choose to put pineapple on their pizza. Now, after that, you may want, and this is like just like general best practices when you're working in n8n and you have like workflows that you like to use as sub workflows elsewhere, have a set node at the end that kind of like sets the output contract. The input contract is based on the trigger. What kind of input is this workflow expecting, and what's the structure of that input? The output contract is based on the set node. What kind of output is this workflow putting out, so that any other workflow that calls it knows exactly what shape the data is going to take. So here I put in a set node, and this really helps because with a set node, you also get to mitigate against the fact that maybe AI one day might not output the data the exact way that you expect it to output it, which is kind of guaranteed. I mean, it's a probabilistic system. So we have the output. We're going to go for the set node. We're going to add a field, so I'll click on that. And the name of this field will be summary. I'm just going to pull the information from the summary variable right here. And now we have the set node giving some kind of summary. You can see it gives an object right here with a summary key and the AI branded summary. Great. We built the summarization agent. Now we're going to build a sentiment analysis agent. Again, I built something similar here, but I'm going to walk you guys through it. So we are going to call this, let's see, sentiment agent. Wow, my spelling is incredible. The sentiment agent. And then I'm just going to like have a trigger, which again is going to be when executed by another workflow. Like I told you, all of the workers expect the same input, the text. So I'm going to have the same thing here, text, and then it's going to be a string. And now you see that you're getting this text. Now, if I go here back to the summarization agent, and I just like copy the text I had on here about pineapple on pizza, we can come back here again, click edit, and edit the output of this node. And I'm gonna add those 2 asterisks because it expects a string, and then paste the text in there. Now, if you do it without the asterisk, it's not gonna be a string, and you're gonna get errors. So you don't want to do that. I'm gonna save that. Now I have this kind of like thing going on. So I have this output. And now this goes into an AI agent, right? And this AI agent is expecting its input from the prompt user message, and I'm going to pull this text in like that. It also expects a system prompt, and it needs to have its output in a specific format. Again, you're going to see a common theme here. If I'm having a sub workflow and I want to push things out and there's AI involved, I'm going to have it outputting its results in a specific format. I'm going to have the structured output parser, which makes it easier to sort of pass data around through workflows. So I'm going to switch that on. And for the system prompt, we can just borrow from whatever we had built before. You can see here it says, let's see. What does it say? You are a sentiment analysis agent. Classify the overall sentiment of the input text as positive, negative, and neutral. Give a 1-sentence explanation, less than 20 words, and then return only valid JSON matching the schema. Again, you give it the schema you expect it to give, right? In this case, an object with 2 keys, sentiment and explanation. And sentiment is going to be a string, and explanation is going to be a string. You can see it by the way it's defined. We come here and we paste that in the system message window, and we have a system prompt. Now we need to wire up this AI agent. We need to give it a chat model. We're gonna go for OpenAI. Since it's sentiment analysis, you can even use ChatGPT 4.0 mini. That's okay. Another option you could add here in the chat, the LLM part, is the temperature. Now, if you know me, you know that I have talked about temperature in the past, which is about making the LLM more deterministic, more predictable. In the case of an agent node, if you hook up the AI node, it's called sampling temperature for OpenAI. I don't know what's called. I actually haven't tried. But here's called sampling temperature. I'm just gonna set it at 0.3. That's my sweet spot. So it's more deterministic. And then I'm gonna add an output parser. Why? Because I had told it to require specific output formats. And this was the format right here. So what I'm actually going to do is I'm going to click on that and copy it. And I'm going to have an output parser right here, right? The structured output parser. You might be wondering why I'm picking the structured output parser. So the different kinds of output parsers. So there's your auto-fixing output parser, the item list output parser, and the structured output parser. This one fixes whatever you're putting out to make it, more sensible, more correct. This one just always outputs an array. This one lets you output whatever kind of output, but you define how it should look. So it's a lot more general. That's why I like it. So I'm gonna go generate from JSON example and then just paste whatever I had in there. So this is what it's supposed to expect. This is an example of that. And then of course, I am going to just run this real quick. And you can see it's outputting an object with a sentiment and an explanation. Now again, magic node, set node, where we have the sentiment. And the sentiment, because you can choose a type, is actually an object. As you can see here, it has a sentiment key with negative and an explanation key. So here in the type, you would say object. And then in here, you would pull the entire output object from the LLM, which gives you the sentiment and everything else. And if you test the step, you'll see that the actual output you get is a sentiment object with a sentiment and explanation key. Maybe we can name this sentiment report or something, just so it's different from the internal key sentiment. Great. So we have the sentiment agent. Of course, click save and you're good. Now we need to do the keywords agent. Again, I've done this before, but we're going to do a new workflow just for kicks, I suppose. Okay, so we have a workflow here, and we're going to call it keywords agent and save that. And then here again, we're going to have when executed by another workflow, and as usual, it is getting text, right, which is a string. And if we test the step, we're going to see that it gives us text null. So we're going to go back to the summarization agent and copy the text we have from here. I'm actually going to copy it along with the quotation marks, so that when I come here and I click on edit, I just come here and I get rid of that, I can just like copy the entire text. Looks like I copied the parentheses as well. That's a bit embarrassing. So I'm just going to take on this, try to copy it a bit better this time, and voila, there we go. Okay, so now we have like pin data in there. Great. Now we have an AI agent as usual, and it's going to have a prompt user message from below, and of course that prompt user message is going to take the text, and it's also going to have a system message. And we're going to borrow the system message from something we had built before, where we say you are a keyword extraction agent. From the provided text, output 8 to 12 distinct keywords or short key phrases that best capture its topics. Prefer nouns or noun phrases, so discard stop words, numbers, and generic terms. I had AI help me come up with this prompt. And then of course at the bottom we give it a shape for the kind of input it's supposed to give. So it's a keywords array with like strings as the items in that array. An array is just like a list of items, really. It's programmer speak. Don't worry about it too much. Sounds fancy, but it really is. But anyway, so we come here and we give it a system message, and we have the user message, and then we're gonna give it a chat model here. As usual, OpenAI, since it's just about keywords, we can again use GPT-4 Minion because we want it to be, you know, do we care about the sampling temperature? It can be as creative as it wants, actually. So let's just leave it at that. And then of course we are going to give it a set node, but let's first like see if the LLM actually outputs what we want. So if I click on this, we can see, oh yeah, so it's outputting keywords and then it does that. So the reason why it's looking so weird is because I forgot to say require specific output format. Again, you know, best practices. And I'm gonna include an output parser, and I'm gonna give it this description as this object shape as like what it should expect. So it should expect like a keywords array with like strings inside it. Okay, now if I run it again, it should now give a proper output with the keywords array. Now we go here and we add a set node, our favorite node so far, and we're gonna add keywords array, and in here we're just gonna like drag the keywords array itself from the previous node. And now if we run this whole thing, we should get that we're getting the keywords array right out there. So we have the sub-workers, we have the summariser, we have the sentiment analyzer, something. And then we have the keywords agent. Now we're gonna go and build the orchestrator. Again, I already built something, but I'm going to do a demo for you guys. So now for this orchestrator agent, just to make it simple, I'm just gonna like right here, orchestrator demo, because I already named the other one orchestrator. I decided to start with a chat input simply because it would be easier to kind of like do a demo, because I just like give it a topic in chat. But then after that, immediately we have the actual orchestrator agent. So we go for AI agent again. Oh, this time it actually comes from the chat trigger node. So connected chat trigger node. So it comes from here. So that one is good. Again, we're gonna need it to give it the output in a specific format. And again, we're gonna give it a system message. Here I have a system message, very interesting one. we're going to look at the system message, and it just says, so goal for any given input text, call three tools. Um, any given input text, call three tools. So summarize the sentiment and the keywords. And this is like, whenever you have an agent and it has tools, you want to describe the tools. You want to tell it about the tools and kind of define the input shape and whatnot, right? So we're going to do this. So with the same text argument. So the tools are independent, do not change their outputs. So this is, okay, I'm just going to dismiss that. Tools are independent, and then after all tool calls finish, respond with JSON exactly matching this shape. So we're going to give it a summary, a sentiment with a label and the explanation, and then the keywords, right? And the rules are always reuse the user's text verbatim in each tool call. Do not add commentary or markdown. And if any tool fails, set its fields to null, but still return valid JSON. These are just like guardrails. Again, I had AI help me develop this prompt, and you should really like try it. It's really cool. AI is getting really good at prompt engineering, so you might not have to do it yourself. I'm just gonna like copy this and paste it. A lot of the rest of the stuff is gonna come from the tool descriptions, but we'll get to that. So we just go here and we give it a system message, and that's pretty much it. Now we give it a chat model here, and that would be OpenAI. So I'll go for, I mean, since this is like about synthesis, you want something slightly more sophisticated. Maybe we can go for GPT 4.1, the latest version, right? And then for the output parser, we're just gonna like borrow the shape of the kind of output it's supposed to give. So this one right here, and we're going to paste it in the output parser. So we're going to pick the structured output parser, and we're gonna have that there. Right? Now, tools, this is where things get interesting. So we know for starters that it calls, so we're going to go this tool line here, right? And then go for call n8n workflow tool. And then, you know, the settings here remain the same. So database, and then the workflow we choose will be like maybe the summarization agent. So where are you? Right there, right? And the workflow inputs. Now this is where it's cool. One option you have is like doing something like, so you change this to an expression, and you would have the curly braces, and then you'd have like the dollar sign, then you say like from AI, like that, and then you like just like call it to like say text or something like that to define the kind of input you give. And this would like directly pull from this AI agent, so from the LLM. Another cool thing is you can bypass all that and just press the stop button, and then it's just going to define automatically by the model. And you can even give it a description, so the text to be summarized. And then you need a tool description right up here, right? So that is what tells the AI what to expect. And there's like a science to this, right? So for example, for the summarization tool, I'll just like pick the message from the tool call here. So I have the Orchestrate actually. I'm gonna pick what I had for the summarization agent. And it's like, call this tool to produce a concise 1 to 3 sentence summary of the input text. So that tells it like how to use that tool. Good descriptions help with tool use. So I'll put that there. And then we're just gonna like rename this maybe to summarization agent. And it's always good to rename your workflows. You'll notice that I didn't do much of that here. So for example, in this workflow for summarization, you should name this a summarization agent. This would be send summary. This would be sentiment analysis agent and send sentiment report. This would be keywords agent. This would be send keywords. So I'm just gonna do that with the overall agent just to make things simpler, because this is where most of the work will be happening, or where you'll be most of the time when you're calling workflows. Next, we'll call the summarization agent. So I'm going to go for call workflow. Again, we're going to go for sentiment agent. So that one right there. And what's the input? Again, we can click on that, and then the AI will define it. And you can add a description. So I had this done somewhere else. So if I go to the sentiment agent, I did add like a simple description here. Call this tool to classify text sentiment and explain in less than 20 words. That's actually for this like top level, but for here I could just say the text to generate a sentiment analysis report for. So something like that, right? And then we can rename this to sentiment agent. And there. So we have a summarization agent hooked up, and now we have a sentiment agent hooked up. Now what we're going to do is we're going to hook up a keywords agent. So call another n8n workflow. I picked the code tool by mistake, sorry. Just going to delete that. Call n8n workflow, and then we are going to pick the keywords agent. Where are you, keywords agent? There you are. Of course, the input will be defined by AI. We'll add a description here. The text to generate keywords for, and then the description. So we'll pick from the orchestrator before. So the keywords agent, and it's just basically call this tool to extract 8 to 12 lowercase keywords or short key phrases. Awesome. We're going to paste that there. And then we're going to rename this to keywords agent, right? And we are going to pull that down here. And we have all our tools. Now, for simplicity, let's say we take just a paragraph right here, right, from the Building Effective Agents article. And we test this workflow. And so I'm going to click on like open chat. I'm just going to like paste this in here. And when I click send, we should see it do all the calls. So it calls all of these. You can see calling them in parallel actually. And it structures the output. And now you can see you're getting output with a summary, the sentiment, the label explanation, and the keywords. How sweet is that? One thing that made this work out is because we had very clearly defined input-output contracts. This is where like things really mess people up when they're doing like AI agents that call another AI agents. You need very clear input-output contracts, otherwise it'll mess you up. I've been there before. Another thing is we had like AIs handling simple tasks, and then we built on this. So you can see in this particular version, if I go back to my whiteboard, we have the AI orchestrating everything, right? It's both orchestrating and synthesizing. There's another version, like for example, here you see that this thing kind of like knows that it just has to do these three things, but like if you want it to be dynamic and it has access to a bunch of agents, you could like connect all those tools here. You could even use MCP, and let me know if you want to make, if you want me to make a video on that. And then it would dynamically decide which agents to call depending on the task you give it. So I gave you a very simple example, which is kind of like predefined. But the beauty of orchestration, you can get as dynamic as you want. You can really get dynamic with the tasks. And maybe I'll even do a future video, like a more complex build, where we can see the dynamism in action. But pretty much that's it. That's orchestration in a nutshell. I'd love to know what you guys think. Of course, with OpenAI credentials, I'll include a link down below in the description so you can figure out how to set that up. But otherwise, next time we're going to look at the evaluator optimizer pattern, and I can't wait. I'm loving these videos with you guys. So until next time, cheers. Bye-bye.